Okay, number 33 is an example of an A-level problem. It's going to be, as you can see from the A through D, quite extensive in solving all of these problems. So I may have to pause a couple times to reset the board. Hopefully the video will play through fairly seamlessly. I may also be jumping pages, as you see right there, and we will see if that works. Okay, first off, we need to find P. And we look like a normal problem. We've got P equals 60 kilograms of our person, and then they give us a distance, which that throws you a little bit, and we need to then, switching color, go to this formula down here, which is all the way from chapter 5 to solve for velocity. This dancer is jumping up in the air and then falling 0.32 meters, so A is going to be 9.8, D is going to be 0.32. We don't have to worry about the DO. The 2 is in there, and the VO is 0, so we don't have to worry about that. So V squared will equal 2 times 9.8 times 3.2. And when we multiply that, 2 times 9.8 times 0.32, we get 6.272, but we need to take the square of that, 6.272, square root of that, excuse me if I said square, and V from this solution is 2.5. We'll round off right there. Okay, 60 multiplied by 2.5 is a P. Let me go back to black to show you we're back into this problem. 150 kilograms times meters per second, or units of momentum. Well, if we know that that's the momentum they hit the floor with, to change the momentum and stop the dancer, we need an impulse equal and opposite to that. So for part B, let's see, let's label this one A. Part B, impulse will equal a negative 150 Newton seconds. Now, if you made, and I'm going to switch colors here, if you made this negative, then that's positive. And either way would work as long as we say they are equal but opposite. In part C, now that we know we have 150 Newton seconds, and they give us a time of 0.050 seconds for the dancer to come to rest, that will cancel. We'll get a high contrast color here. Cancel. And now 150 divided by 0.050 will equal approximately 3,000 newtons. Okay, 3,000 newtons. Finally, D. And this is where, in an A-level question, we're doing a comparison that, there's no direct formula for this. You'd have to put a few steps together, including memory from the past. The exact problem reads, compare the stopping force to the dancer's weight. And you might say, 3,000 compared to the 60 kilograms, and just take 3,000 divided by 60 kilograms and say, the force would be 50 times greater. But that would be incorrect, because 60 kilograms is not the weight. That's the mass of the dancer. We need to take 60 times 9.8. 60 times 9.8 is 588 newtons. This is the weight of the dancer. So if we take 3,000 and divide by 588, we come up with an answer of 5.1 times greater than the weight. And there you go. That's the solution.